Hello everyone, let's do AP Precalculus 2024 free response question, and this is question number 3 from the non-calculator section. So this is a modeling question, specifically a sinusoidal modeling graph function. So let's try and understand the question properly first. It says that the tire of a car has a radius of 9 inches and a person rolls the tire forward at a constant rate on the level ground as shown in the figure. Now point W, if you look at here, is on the edge of the tire that touches the ground at t equal to half second. Then the tire completes a full rotation, and the next time the tire touches the ground, or the point W touches the ground, it is at t is equal to 5 by 2 seconds. So approximately from half a second to 2.5 seconds. So it takes 2 seconds for one complete revolution. So this is an important point and will help us. It will actually help us to form the period of the graph. Next, we have the maximum height above the ground is 18 inches. As the tire rolls, the height of W above the ground periodically increases and decreases. Now, this is something as a graph we need to understand how is the height of the tire increasing and decreasing. So when the tire touches the ground, we can see that this point W touches the ground at half a second, and necessarily after 2 seconds it comes back and touches the ground once again, right? Now there are 4 different points on the tire which we can take reference of, which we can divide the period into specifically. And since the period is of 2 seconds, dividing it by 4 gives us after every 0.5 seconds there's a change in the height. Ideally there's a change every time, but we divide it into 4 parts to look at the graph clearly. Now after 0.5 seconds, which means if this was a 0.5 seconds, and we don't know the height yet, but yes, since it's at the ground, the height is 0. We are trying to establish a relationship between the time and the height. Now after 0.5 seconds, which means now 1 second will be done and the height will be something above the ground. After another 0.5 seconds, it will be 1.5 and height above the ground. And since this is a maximum height above the ground, it has been given in the question, it is 18 inches. So the height will be 18 inches when time is 1.5 seconds. Going again ahead, after 0.5 seconds, it will be 2 seconds once again. And 2 seconds, the height will be another something about which we will check what the height will be. And again, after 2.5 seconds, as it says 5 by 2 seconds, it again touches the ground. Now to think about it, what would be the height here at this point of reference? Since the radius of the tire is 9, which will be the same as this height, the height at these 2 points will also be 9. And because of that same idea, the maximum height, which has been explicitly mentioned in the question as 18, we could have also thought about would be 18 because it will be diameter of the circle. So we have got the points of references which are at half a second, which is 0.5 second, height is 0. Then at 1 second, it's 9, 1.5 second, 18, 2 seconds, it's 9. And again at 2.5 second, it again becomes 0, which we can again mention here as 2.5, 0. So these are the points of reference. Now they're saying the sinusoidal function h models the height of the point W above the ground in inches as function of time t. So height has been modeled, ht has been modeled dependent upon t as a function of time, and it's a sinusoidal graph which we will divide into 4 equal parts to get the function, just like we have divided the rotation of the tire into 4 equal parts. That's why we did it into 4 equal parts, to understand the rotation of this sinusoidal graph. Now graph of h and its dashed middle line for 2 full cycles is shown. F, G, J, K and P are the coordinates labeled on the graph. We have to determine the possible coordinates t, h of t for the 5 points F, G, J, K and P. Now let's understand the idea that when I look at the sinusoidal graph, F and P are points of maximum height, while J is the point of minimum height. And when I look at the tire, it also shows me that there's maximum height is 18, minimum height is 0, and then there's a middle value which is 9 for both of them, right? So which means we can say that this line, which is exactly like the dashed line in the middle, can act as the line of ht equal to 9. This can act as ht equal to 0, and this can act as ht equal to 18, which is maximum. Now let's see at what all points are we getting the maximum value, what all points are we getting 9, and what all points are we getting 0. Now 0 is where the point starts from, which should ideally be somewhere around here, which is 0.5 second. 0.5 comma 0, because at 0.5 the height is 0. If you want to still go back onto 0 comma 0 where it was, then again reducing it down by 5 units, you can have another point. It will be at 9. So this point which you're looking at will be 0 comma 9, because the graph starts from that point and the height is 9 seconds at that point. So after 0.5 seconds the height is 0. Then this point which is on the dashed line will be 1 comma 9 for reference, because again after 0.5 seconds the height becomes 9. Another 0.5 seconds the height becomes the maximum 1.5 comma 18. At g again it reduces down, which is 2 comma 9, because 0.5 seconds the height is at the dashed line. So this way we can continue forward and write down the coordinates of a point. So for f we are getting the point 1.5 comma 18. Another value for now g will be increased by 0.5, and the height is at the dashed line, which is 9. Now j is the minimum most point, and it will be obtained at another 0.5 increase of 0.5 seconds, which will be 2.5 comma 0, which also has been given in the question. At 5 by 2 seconds it touches the ground, which is the minimum most height. Then again the point k is after another 3 seconds, another 0.5 seconds, which is 3 seconds, and since it's on the dashed line it is 9. Point P, if you look at, is again after 0.5 seconds, which is 3.5, and it gives the maximum value, which is 80. So these are our points of references which have been given in the graph, which we can label by understanding the cycle of the rotation of the tire. That is what is most important. Now, the next part the question says is to use these coordinates and the information given to form a sinusoidal function. ht is a sine bt plus c plus d. So a times sine of bt plus c plus d. Now, if you should know that a in this case indicates the period, or is useful for the period, and is useful for the amplitude, not the period. Then B is something which is in reference with the period. You calculate B using the period. C is what is useful for the horizontal translation. And D, if we look at, is reference for the vertical translation. Now, looking at the graph that we have, an ideal sine graph starts at the origin. We know it starts like this, goes up first, then comes down, and again goes back. So this is what an ideal sine x graph looks like. Now, first identifying what is the amplitude of the function. If we look at the points of reference between the middle line and the highest point and the dashed line, that has a distance of 9 units. Hence, we can say A, which is the amplitude, is 9 units. Going on ahead, we have to discuss about the period as well. We discussed the period is 2 seconds. Now, the formula for calculating the period is 2 pi over b. Since we have the value of period is 2 pi over b, b will give me a value of pi. So we can say b is pi, then in that case, a has come out to be 9. Now to look at for the values of c and d, we have to look at the translation of the graph ideally. How has it become? Now, if I look at this point of reference, which is the starting point, this one was 1 comma 9. And my sine graph ideally starts from this point, goes up first and doesn't go down. That is why I cannot start from this graph. Otherwise, I'll have to change the amplitude to negative. So to make it easier for me and less confusing, I am assuming that this is the point of start for my sine graph. So I can remove this area so that it's, not confusing at all. So I'm assuming that this is the point of start of my sine graph. It goes up, then goes down. So from 1 comma 9 all the way up till k is my one revolution of the tire. So 1 comma 9 all the way up till k is one revolution of the tire, or we can say one period of the graph. Now according to this, ideally the sine graph which starts from 0 0 has shifted to 1 comma 9. Since it shifted 1 units to the right and 9 units upward, we can identify the horizontal and the vertical translation. Because the horizontal translation happens in the form of x minus h, we can say the value of c is -1 and d hence is +9 because it shifted 9 units upward from the origin. Therefore, the value of my sinusoidal function h of t can be written as a, which was 9, so 9 sine pi times t minus 1 because it will help it shift to the right, plus 9 which will help it shift upwards. So this is what my sinusoidal graph I have modeled using the information given below. After you get the coordinates, it is just about understanding the translation of the graph, the period and the amplitude to understand the sinusoidal function and model it. Let's answer some more questions. It says refer to the graph H in part A and the t coordinate of K is T1 and t coordinate of P is K2. So which means they are talking about this part of the graph from K to P. They are saying on this interval from T1 comma T2, T1 and T2 are nothing but x coordinates of K and P. What do you think is true about H? Is H positive and increasing, positive and decreasing, negative and increasing, and H is negative and decreasing? So if I look at it, the values of the coordinates are obviously 9 and 18, which means they're definitely positive. So any of option A and B will work. But it also says whether it's increasing or decreasing. So we can clearly see from K to P, the graph is increasing. Hence our answer will be that H is positive and increasing. Now understanding the second part, it says describe how the rate of change of h is changing on this interval. Now if we look at the graph from t1, t2, which is the graph from k to p, the function is concave down. And since the function is concave down, we can say the rate of change is decreasing because it's concave down. And the graph, although the rate of change is positive, however, it is decreasing because it is concave down. So we can write down the rate of change is decreasing as well as positive whenever on the interval T1 to T2. So this was a good sinusoidal modeling graph. The last part of the questions are easy. However, the main challenge comes in identifying the values of A, B, and C and D and understanding the period of this tire question that they have given us. So hope you understood the problem.